All right. All right, we are going to start shortly. So let me know if the audio and video quality are fine. All right, so let's start our discussion today. And as expected, we are going to talk about Python functions today. All right. All right. All right. So now let's not talk about Python functions. Let's talk about generic functions. What kind of functions do you know about, right? So you have studied mathematics, right? And in mathematics you have studied functions, right? And now say, what is a function? Now of course there is a huge, if I say what is a function, then of course the definition should be, and of course in mathematics everything must be rigorous, right? Everything must be precise and perfect. So of course let's not think about mathematics at the moment, but let me assure you that all the programming languages that we have today came from very strong mathematical backgrounds, right? People who created programming languages, created compilers and everything, they had very strong mathematical background. So essentially, once again, if you don't know your mathematics well, you won't be able to do much with your computer programming skills. Or if you are trying to invent a programming language, of course you would need to have a good mathematical skill set. All right. So with that said, let me let's say what a function is, right? In general, I'm having some trouble writing today. So what a function is, for example, I can say function, since we are studying control system engineering, I can think of a function like a box, okay, which takes certain inputs, say a few inputs, and returns certain outputs, something like that. So for a function we would have certain inputs and certain outputs. Yeah, I'm okay. Those who are asking about my health, actually I have some issue here, okay. So if I, for example, speak loudly for a very long time, like whenever I'm taking your classes and making a live stream like this, what happens is after that my throats become really sore, and my throat becomes really sore, and usually what happens, then I need to go for a rest after that. So yes, I did checkups, and yeah, I'm fine, more or less. So I call this a function. Let's say it's a function, and say denoted by this. All right, something goes there, and that's an operator, right? So that's how a function is defined, right? So in computer science terminology or programming language terminology, okay, these inputs are known as input parameters. Input values or parameters. Okay, input values or parameters, and these outputs are called returns. So in programming language terminology, if you have a function, then the function is probably going to take certain inputs and parameters, and it's going to generate some output, right? All right. So, but with that said, a function does not need to have a traditional input, or does not need to have a traditional output. So what I mean by that is, I can have a function in a programming language. For example, in Python, I can have a function which does not take any input. Okay. Also, I can have a function which takes certain inputs but does not produce any output. Also, we can have functions, okay, that does not take any input, does not produce any output, but it does something that I would probably need. So all these possibilities are there. So this input-output terminology of a function is not directly applicable for programming languages for the most part, because you understand that these inputs and outputs are not mandatory for functions. I can have a function that does not take any input, does not produce any output per se. Okay, does not return any output. Okay, all right. And just like our typical block diagram algebra that you have studied, what you can do, you can take the output of one function and feed it to the input of another function, right? So if one function generates an output like this, you can take it and feed it to another function, so that you have a cascaded system, for example. Okay, right? So you can take the output of one function and feed it back to one input. Something. All these kind of things can be easily done, because the moment you think about a function like a block, and the block carries certain inputs and produces output, then of course you can think about the other terminologies, that other nomenclature that actually comes in association with that understanding. All right. Yes, a function can be a logic gate. A function can be like a block, right? It is supposed to take certain inputs and produce certain outputs, but it does not need to, right? Okay, so we are going to see all these kinds of examples. All right, so with that said, let's jump into Python programming, right? So of course I have Google Colab opened. Let's switch to that. So again, those who don't know what I'm talking about, open colab.research.google.com. So open this website. So what I'm just pasting on the live chat. So open this, and again, I would strongly urge you to follow along. Unless you follow along properly, you won't be able to understand what I'm talking about. All right. All right. So with that said, try opening this link. I mean, again, and create a new notebook, new Python 3 notebook. All right. With that, I would assume that you understood one of the very important points that we raised in our last session on this, that in Python, the scope of a block is often determined by tabs, right? Often determined by indentation, right? So we created for loops. For example, I would have certain lines, so I would have a for statement, for example, and after that, everything that comes into the for loop would be indented, right? That tab would determine or tell the Python compiler that whatever comes after that is actually a part of the for loop. That will also the same with if blocks, okay? Also the same with while blocks. So essentially, the scope is pretty much determined, okay, by an indentation. So indentation is part of Python's syntax. So I believe you took that at least from the last class, right? Now, why am I saying this? I'm saying this simply because that concept of indentation will once again appear here, right? So whatever we want to write inside a function, the mechanism inside a function, okay, that will appear under an indentation block after a function, right? So let's create a very simple mathematical function, right? Let's create a very simple mathematical function, and let me switch to this. For example, let's create a very simple mathematical function. Again, I'm trying to keep this idea as simple as possible so that anyone who has zero knowledge of programming languages whatsoever can follow, right? I could easily switch this up to intermediate class, where actually I would kind of rush along quite a few things. But I mean, as far as I am concerned in this course, I'm trying to keep this course as simple as possible, and I mean for absolute beginners. Okay. So the point is, so for example, I want to create a function. What it does is it takes an input. For example, it takes x. Okay, and it essentially what it does, it squares the number up and returns output. So essentially, if you provide x, you would get x square. So you have something like that, and of course you can think about this as a static system, right? So I want a function like that, right? And of course, just like any object in Python, usually you would need to put a name for that, right? So this function needs to have a name for itself, right? So you can call this an so for example, if the function could be named if, for example, right? So with that said, the function would be something like if x, and it returns x square, something like that, right? Of course, now this kind of name like if, x, y, this kind of names are not really encouraged in Python, because the understanding is that your name should be declarative. Your name should be kind of representative of what it does, right? So if you create a function that squares a number, then maybe you want to call your function to be something called square num. I don't know, but at least by looking at the name, people should have some understanding what your function does, what the objective of your function is, right? So instead of calling your function f, x, y, z, whatever, okay, so you want to call your function with a proper name that actually tells you what the function does, I mean at a glance, right? So that people don't have to look around and figure out what the function actually does. This is again not a syntactical criteria, but this is very strongly recommended that and this is not just for Python, it is strongly recommended in any programming language that the functions, the variables that you create should have some sensible naming scheme, right? So if you are putting coordinates, don't just write x equal to something, y equal to something, right? For example, just to give you an example, for example, if you want to create coordinates, for example, don't write x equal to something, x coordinate, say x coordinate 3, y coordinate 5. Don't write like that. I mean, people might figure out what these things are, of course, by looking at the context, but instead a better naming scheme would be something like this. Say code underscore x, similarly code underscore y. So by looking at these names, of course, people would, of course, with a very high likelihood, people would understand that we are talking about coordinate x and coordinate y. So these things should be kept in mind, that your naming scheme should be sensible. People should be able to understand what you are trying to achieve by just looking at the things, okay, without reading the comments. So again, as the saying goes, a code is, I mean, most beautiful when you can read and understand it without looking at the comments. So right, so if you don't if you create a code that does not require comment, or at least requires very few comments, then that's actually beautiful code, because it is supposed that people can understand your code by just looking at it without reading the comments, right? Without hunting through the comments. So that's the idea here. Okay, so very simple things, but okay. All right, so again, so as I said, I'm going to create a function with a sensible name. Again, this is the syntax now. Again, is the zoom fine, or do I have to zoom it even further? Okay, let me zoom it further. All right, I think this is fine, right? All right. All right, let's define a function. So all right, so again, the syntax is you write def, and def is definition, so function definition. So this syntax is used for function only. Okay, if you're creating a class, then you would say class and then name of the class. Okay, so def and then name of the function, right? And here you put the arguments. Okay, This is very, and just notice the difference between this definition and the definition used in C and other programming languages. You are not saying what your function returns, right? So in the function definition, you don't have to say what your function returns, right? So here, say x is the input, right? X is the input. Fine. Again, using this kind of name is not a good idea, but again, we are doing a very simple program per se. So what we are trying to do, we are trying to return a value, right? So what are we trying to return here? Return x square, and I believe you know the syntax for x square, right? So that's your very first function, right? A very simple function that takes x and returns x square. So x goes into the function as the input and x square comes out of the function as an output, right? So all I have to do is to run the function, and of course the first running takes a little bit of time in Google Colab. And again, I'm strongly requesting you to actually do this yourself. Open a Google Colab session and try following along. Right? So now I have just started this session, right? Let me type in whose and hit enter. Let me type in whose and okay, fine. So what you see is that, again, I told you that whose, whenever I type whose and run it, it shows me every name present in my current namespace. So in my current namespace, I have, so it says it's a variable, right? So this name, I have a name like square num, but what is this name? This name is referring to a function, right? So what is this square num? This square num is a function. Got it? This square num is a function. So with that said, now I can call this function. Okay. So how do you call this function? Simply like calling fx, for example. So if I say square num and say, for example, say I send in 5 and hit run this, of course I'm going to get 25. But is that it? Is that it? So in an earlier class, I told you that Python is more, both strongly typed and dynamically typed, which means that if I pass in some other type of variable, for example, I passed in an integer, it returned an integer. I can pass in a float, it will return a float. Maybe I named it wrong. Alright. So if I pass in a float, it will return a float. Okay, understandable. That's pretty understandable, right? Okay. So similarly, so the problem is that I have my drawing pad right here. I cannot really type. Okay. What if I pass in a complex number? Of course, that also works, because I can take the square of a complex number, right? Python can take the square of a complex number. That's fine. So as long as I pass in an object which can be squared, at least in the common terminology, Python can return the square of that particular output. I didn't have to think about different types. Right? So if you wanted to do this in something like C++, you would have to create something called a template. You would have to create something called a function template. Okay. All right. So with that said, you understand the power of this, right? It's very simple. Again, the idea is that it's very simple, right? A function can call itself as many times as it wants. And of course, for example, I can say so what happens here, if I run this, what happens? This one is executed, so I get 9, then 9 is squared, and then 9 squared is squared, right? So yes, a function can call itself as many times as it wants, right? With different arguments. So understandably, you can see that this one, this inner one was actually called with an argument of 3. Then whatever that returned went into the same function with that value, and whatever this function returned went to this outer one as the input, right? And so we have this output. Again, anytime you have any difficulty understanding my point, feel free to ask. Alright, so I think, this is quite understandable, right? Again, it's not difficult to understand at all, right? Alright, so I said a function can take multiple input, multiple outputs, and generate multiple outputs, right? It can take basically m number of inputs and generate n number of outputs. Does not matter. A function, and that m and n could be 0 as well. So a function might take no input and might produce no output. So let me show you a function that does not take any input, for example, right? So let's create a function. So I'm creating a function without input. So I would define, right? So now, of course, I have just created a function. So the name of the function is function without input, for example, and I haven't given any input. So I have put a colon here, and I have entered a new line. Of course, there is an indentation. So this is an indentation block. And here I can return something. For example, let's say return this is a function with no input, right? So what happens is I have defined a function that does not require any input, but it generates an output, right? It generates an output, and in specifically the output here is a string. It generates a string, right? Again, the output or input can be any. The input to a function and the output of a function could be any Python data structure. Any Python data structure, any data structure that you have created maybe, okay? So any valid Python data structure can act as an input and also as an output of a function, right? The data structure could be built in or could be something that you have created, right? So again, it's a very simple function that does not require any input. Again, the placeholder for the input is empty. I haven't given any input, and this is the return output. Okay, so the function does not take any input and it generates an output, right? So if I say, so how do I call this function? I just call this function without any argument. Okay, open braces or open bracket, open parenthesis, close parenthesis, right? So open and close parenthesis. So I have that. So there is no input here anymore, right? So since there is no input, of course it does not expect any input either. So if I run this, of course the output would be this. All right, very simple, right? All right. Now say I say x equal to this. So what I'm essentially doing, I'm executing this function, and after executing this function, whatever the function returns, I'm assigning that to a variable name x. Okay, so whatever this function returns, I'm assigning that to a variable name x. So if I do that, I don't see any output, but what if I print x? If I print x, of course x is now a string that was returned by the particular function that I just called here, and that was assigned to x, and now we have a string connected with x, right? So that's the output, right? All right. So of course we can have that without any issue. All right. Now see what happens when we try to call a function with unexpected arguments, right? So this function did not expect any input, but what if I send certain inputs? So this is kind of unexpected, right? So this input was unexpected for this. So unexpected. So this input was unexpected, right? And what? Right? This input was unexpected for this function. So if I run this, What does it say? See very carefully. It says that we now have a Python error which says type error. This function, with the name of the function it gives, takes 0 positional arguments, but 1 was given. So which says that it expected 0 inputs, you gave it 1 input, right? So it did not want any input, it expected 0 input. Now this term positional argument, I will clear this up shortly. Okay, so in Python functions you have 2 types of arguments, positional argument and named arguments, and I'm going to talk about that. Positional arguments and named arguments. All right. All right. Again, so this is understood, right? This is very simple to understand, right? So let's now create a function that has multiple inputs and produces 1 output. Then I will show you a function that takes multiple inputs and produces multiple outputs. Okay, so let's create a function that takes multiple inputs, right? So let's say this is the parabola. So this is a point on a parabola, right? So you're just creating a point on a parabola, and a parabola is essentially a quadratic curve, right? A second order curve, second order polynomial, right? And of course, for a second order polynomial, I would have 3 coefficients a, b, and c, right? So if I say ax square plus bx plus c, right? So, and of course, I would have a value of x, for example. So I would have a, b, c, and x, right? So the output that I want is essentially y, right? Y would be a x square plus bx plus c, right? So that was the output, and let's return that. So if you pass in the parameter value a, b, c and pass in the variable, the value x as well, so you get a point on the parabola, right? So essentially like that. So now I can call my function and say a is 1, b is 2, c is 4, and x is, for example, 20. Now of course it did calculate everything. It calculated ax square plus bx plus c, and of course this was x, right? It calculated, right? So it returned 1 output, right? All right. Now sometimes what happens, so this is again a very simple example, right? A function taking multiple inputs and producing 1 output. This is a very simple example as well. Now sometimes what happens is our function that we are trying to create takes multiple inputs maybe, but produces multiple outputs. The important point is our function can produce multiple outputs. Now of course, those who haven't done much of C programming, you don't know how difficult it is to create a function in C that returns multiple values, right? So you cannot even return an array in C, right? A function in C cannot return an array. It can only return a pointer to an array. So your function, if you want multiple values to be returned, essentially if you want an array to be returned in a C function, all you can do, you can return a pointer to that array. Okay, so yes, I mean things are syntactically pretty difficult, but in Python, any Python object can act as the input of a function, any number of them. So any number of any Python object can act as an input to a function, and the function can return any number of any type of Python object, right? So you can return very different objects like that. So let me, but someone is saying, or we have to print in loop. But the problem is, if you print something, you are not returning the value, right? So for example, if you have created a C function, for example, where you are printing the output, that print is good for you, but that print is not good for any program, right? You cannot assign that print value to another variable or something, right? Right? Do you get my point? So if your function is returning 2 value, and instead of just returning them, if you're somehow printing them, you cannot assign those 2 values to a new variable, right? You are a human, you can see the results. But if you're doing that inside a computer program where you probably would want to assign those values to another variable maybe, or pass in those values as arguments to another function maybe, You cannot do it with a print statement, right? You cannot do it with a print function, right? You cannot just print them. You get the point, right? Your function should return certain value so that that return can be taken by some other functions or other variables, right? So with that said, I think my point is clear. Now, with that said, let's create a function in Python that actually returns multiple things. And again, the syntax is really easy, really easy. So let's create a function, a very simple function that takes no argument but returns multiple values. So again, the name of these functions that I'm choosing right now are pretty self-explanatory, right? So I'm creating a function that returns multiple things. So I named my function multi-return. Okay, and it does not take any input, for example, at the moment, right? Just to show you. So I can return different Python objects, okay, and as many as I want, for example. So if I want two values to be returned, then all I have to do is to put a comma between those values that I want to return, right? You understand what I'm saying? Okay, so this function is essentially going to return 3 and 5. Okay, so if I run this and say of course this is going to return two values, right? So if I say x comma y, and then I can say, I can call this function. So essentially now what happens, this function returned two values. One of them was 3, one of them was 5, and 3 would have been assigned to x and 5 would have been assigned to y. So I can verify that. I can say print x, of course x is 3. I can print y, of course x is 5, y is 5, right? So I can do that again without any issue. So it returns multiple things, right? Very simple. And now whatever it returns does not have to be of the same type, right? Let's say take this take this function. Let me take this function, put it here. Somehow my computer CPU is pinned down. Just hold on a bit. Something is going wrong with this. Alright, so my computer CPU is pinned down, I think. Let me close a few processes. Alright. Alright, I think this works now. Alright, fine. Alright, so now maybe I want to return two values. Say for example, I'm returning one value that I calculated, and maybe I would return a string, for example. So I would return a string. This is a parabola. Now this function actually returns two values. For example, now if I say, now if I run this function right now, so for example, say parabola, and say for example 1, 2, 4 and 20, whatever value I gave it earlier. Now it returns two things. Now what is it returning? It is returning one integer, and it is also returning one string that I gave it with a comma here, right? So the point was, yeah, a sudden lag was happening because the CPU was actually pinned down somehow. I have to check what is happening here. Alright, so with that said, so that you understand, so this function is supposed to return two values, but what it instead returning is a tuple. So whenever we return multiple values out of a function returns a tuple. So you can recall a tuple as an immutable list. Okay, a tuple as an immutable list. So what I'm doing, what it returns actually, it actually returns a tuple. So tuple is an immutable list. So it's like a list. Okay, it's like a list, but the objects there are not changeable, right? So of course you can do your fancy tuple assignment. So what you can do, try to understand, whenever your function returns multiple values, say for example, if you say this is equal to y, then y is now a tuple, right? So I can say, I can see the type of y is now a tuple. So y is a tuple because it has, or sometimes people call it tuple, okay, I call it tuple. So y is a tuple and it has two values, right? For example, here in this particular scenario. So y is that. So now I can, of course, on this I can do indexing. So if I say y0, I am getting the first output of this function. So this function was returning two outputs. So one, a point on the ordinate of a point on the parabola, and the other one was the string. So you can do this tuple assignment and do this, right? Or you could just call this function, and since you already knew that this function returned two values, then I could say, I could assign two variables right when I called this function. So I could say that this is the ordinate, so the y value, and this is the whatever log, for example, maybe a string. So now with that said, this string variable would be assigned with this string, and this ordinate variable would be assigned with the result that I had. So basically, so now if I say, if I want to print ordinate, so that would be this, and I can say string, that would be this. All right. And again, if you are facing lag or something, please let me know. Okay, because I cannot end the stream to troubleshoot what happened. All right, so I think this is fine, right? All right. So again, I told you that there are functions that do not return anything, that do not take anything. Okay, just let me give you an example, right? So this function is not taking any input and not returning anything. So this function would not have any return statement, but this function would probably end up printing something or doing something. Say, for example, print. Now, with that said, whenever I run this function, okay, this is going to be printed, but you might be tempted by thinking that, you might be tempted to think that this was the output of the function. You might be tempted to think that this was the output of the function, but this isn't. Okay. Yeah, there is a little bit of lag, I think. There is a little bit of lag throughout the stream, unfortunately. Okay, OBS is not lagging. Hold on. I am having certain technical issues, right? Okay, there is a bit of lag, but I think you can hear me right? I think you can hear me properly, right? So if you can hear me properly, then that's a non-issue, right? Okay. All right. So don't look at my face. All right. So now this might look like a function returning something, but it is not returning anything. It is only printing a value. So, and that will be evident if I want to assign something. Say if I say x equal to nothing called, then it would say, see, so it printed something. But what is x? If I want to print the value of x, what is x? X has got nothing, really, because this function did not return anything. Okay, try to understand. This function did not return anything, and that is why x did not get anything. This function only printed this value. This function did not return anything. Okay. So if my head is actually, I think this is becoming laggy, right? Okay, okay. Let it be like what it is today. Anyway. Alright, so I think this is fine at this point, right? So by returning, by printing something or doing something like that, you are not returning any value. Again, a Python function does not essentially need certain inputs, and Python function do not require to have outputs, but they can have inputs and output, multiples of them, right? You can return as many as you want. You can return multiple objects like that. So you can return one list, one string, whatever, right? You can do any of these things. All right, your function might not return anything. But one of the main point I'm going to tell you right now is that, so those who are coming from something like Java, something more Java background maybe, so you have heard of something called function overloading, right? Method overloading, function overloading, right? Overloading. So what you essentially have in those languages is that you define the same function in many different ways so that many different use cases can be handled, right? Now, some people call it a feature, and I, along with many other people, would call it something like a severe disability of a language, right? I mean, why? Because in Java, you don't have something called named arguments. What I mean is this. So right now, the point I'm going to make here is something called named arguments. Okay, so named arguments. So you have seen this function, right? You have seen these functions. Let me just write a function very simple. So let me just again call this parabola function, right? The function I took earlier. Let's take this and let's just return one value, huh? Return y. All right. Let's just return y without any problem, right? It's a very simple function, right? The point is, if I did this in Java, did this in C, for example, all I had to, I could only call this function in this way. Parabola, I could only call this function in this way. Something like that. So first I had to pass in the value of A, then I had to pass in the value of B, then I had to pass in the value of C, and then the value of X. Then whatever I got, I have it here. Right? All right. You get the point. Now, the thing is, since Python supports something called named arguments, I can do something like this. I can say, and for example, say I can say X has a value of, I can say X has a value of 30, A has a value of 1, B has a value of 2, and C has a value of 5. See, I just completely changed the order in which the variables were supposed to be passed into the function. I have completely changed the order, but since I am giving their names along with the value assigned, I end up with the exactly same result. So this is called the named argument feature of Python. So in Python, all the arguments of a function have names, actually names, right? They have their positions and they have their names as well. So you can essentially call them with their positions. So basically here, you are not saying A is equal to 1. You are just passing 1 where A was there. Similarly, you are not saying B is equal to 2, but just you are passing 2 where B was there. Similarly, you are not saying C is equal to 5, but you are just passing 5 in the place of C, and that's for X. But here, you are specifically mentioning that X is equal to 30. So wherever X resided, that will be assigned to 30. And then you are saying A is equal to 1, B is equal to 2, C is equal to 5. So with this named argument scheme, you can change the order in which you pass in the variables. You pass in the values, right? You can change the orders in which you pass in the values. So you can do that. Now this has very powerful features I'm going to tell you. Now, why is this important? Sometimes what happens is that the function that you have created has many different arguments, and sometimes just passing in values, like for example, somebody who is just joining the class, for example, and seeing this, okay, just I have called a function whose name is parabola. Probably it talks about parabola. But what are these values? What is this 1? What is this 2? What is this 5? What is this 30? Right? Right? Do you get the point? Somebody asks, so for example, what is this 1? Right? It might as well be X, right? This could be A, this could be B, this could be C, right? So by just looking at this function, you do not right away know what this function actually really have as the arguments, right? This talks about a parabola, so probably this is a quadratic function, right? Quadratic polynomial, second order polynomial. But what are these values? I mean, they must part into X, A, B, and C. But which one is which? By just looking at it, you don't really know. But look at the second call here. If I call the function this way, okay, I can of course mix and match. I can mix and match. For example, I can write x equal to 30 here. And then I can pass on these values, same result. But just again, even though I call this function by mixing and matching the variables like that, but by just looking at it, somebody would know, okay, it's a parabola, fine. So it's a quadratic polynomial. And okay, a is one parameter, of course, that is the value of 1. X is the value of the abscissa, that's 30. B is another parameter, and C is another constant, right? So by just looking at it, you'll be able to actually see what the what I'm passing in into the function, right? So again, this is one of the fundamental ideas in Python, that your program must be readable. So the named argument property in named argument scheme here in Python does not only simplify the fact that you don't have to overload a function and write many different functions, many different versions of the same function, but instead what you have, along with that, what you have is a good readability of the function. So it is often recommended that unless it is absolutely understandable by just looking at the function, you always pass in the variables as named arguments. It is recommended that unless the function that you are calling is absolutely understandable, that what it takes actually. For example, if I say, if I call the sine function from the math library, right? I do not really have to say x equal to something, because it is understood that sine would take one argument and that value has to be in radians, right? Every single person understands that. So that way I do not have to use named arguments here. But if I am using a function of my for example, if I'm using a function that I made maybe, or a function that is not so regular like that, then in that case I am supposed to, or rather I am strongly recommended that you use named arguments, so that by looking at your code, people understands what you actually want to do, what you actually are trying to do, right? Along with that, Python supports many other different things. With named arguments, you have something called optional arguments. Okay, so optional arguments, or rather I like to call them, or rather many people like to call them, default arguments. Okay, default arguments. Now let's talk about default arguments. Now say, let's talk about this parabola function once again. So I'm just modifying this function so many times, right? Now what I'm doing, so for example, I'm making certain default values with this function. So for example, so a equal to 1, b is equal to 2, and c is equal to 5. Okay, something like that. What happened? Sorry, I have to pass in x first. Okay, that's the problem, right? Oh, hold on. Okay, named arguments come later on, right? So right, so what if I say, what would this one return? Try to guess. So I'm now calling this function with this value, okay, 30. I have not passed x, I have not passed y, I have not passed a, I have not passed b, I have not passed c, I have just passed x, right? One variable only. Guess what I'm going to get? Am I going to get an error? All right, so all right, someone is saying that of course probably no error, right? Let's run this. Of course we did not get any error. So this is the idea of default arguments. Sometimes what happens is that in your program you do not always want to have different values, right? You sometimes want to have certain default constants. All right, sometimes you would want to have default constants, for example. So for example, here I have a is equal to 1, b is equal to 2, and c is equal to 5. These are now default values in my function, for example, right? Default values in my function. So let me so now that's fine, right? So if I pass in 30, it understands that I am trying to pass 30 as the value for x, and I'm getting the output as that, right? So now with that said, right, so now I can pass in the value of x, for example, say x equal to, say for example, I don't know, maybe 30, but say I want to just modify the value of b. So I will run with the default values for a and c, but maybe I would want to modify the default value of b. Instead of having it at 2, I am going to assign it 3. So see what happens. X will be assigned 30 and b would be assigned 3. And for the rest of the parameters and variables a and c, all the default values will be assumed. See, now we have like that. So these are now default arguments in Python, right? All right. So now in this function, this x is called a positional argument, okay? And these arguments are known as named arguments, right? Yes, someone is asking if I say say if I say something like this, say for example 30, someone is saying 31 to something like 31, I cannot type somehow, 2 and 8. Yes, all the arguments changed actually, really. So x is now 30, a is 1, b is 2, c is 8, right? 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 But what if I just wanted to change? So this way you are changing everything, right? So this way you are changing everything. So now the point is, all of these are positional arguments. But if you treat them as positional arguments, and if you want to change any one of their values, then what happens? You have to write down all the values. Say here, a was by default 1, right? So here a is also 1. B is by default 2. B is also 2. But we have changed C like that. So this could have been just achieved. So here what happens is the value of x is 30. A is 1. B is 2. So A and B are coming with default values and C is 8. So this could have been achieved by saying x is 30. So I am passing in 30 and only I am changing the value of C. So I am not modifying the value of A and B. So I would get the same result. So that is how you use default parameters. And also notice very carefully that I could say this. I could say x equal to this. This is fine. So of course this is understandable. It's the same thing, right? This is fine. Right. So I could say x equal to 30, c equal to 8. So a and b will get their default values like 1 and 2. And x will be 30, c will be 8. This is fine. This is fine. But if I take this one, right? Same thing, right? A and B are 1 and 2, like the default values. X is 30, C is 8. Someone is asking, okay. So if I take this and say, now if I say x equal to 30, something like that, it should work, right? But it does not. It is not fine. And the reason that it is not fine has been given. It's a syntax error in Python. It says positional argument follows keyword arguments. So this is wrong. This cannot happen. The point is, positional arguments must appear before you are having named arguments. or rather keyword arguments. So these are named arguments or keyword arguments. So try to understand what I'm saying here is that I'm saying x equal to something, but the moment in Python programming, so if you say, so again, just go back. So now if you are writing something like this, okay, so here, so look at this one very carefully. Here x is equal to 30, but I did not say x equal to 30, right? Here I did say x equal to 30. Look at this one. Here I did say x equal to 30. It meant that I used the name x and assigned a value 30. But here also x is equal to 30. But this happened to be in a different way. So I used the position of x to assign a value to it. So this argument appeared as a positional argument, right? So the position of x was the first here. So I could just say 30 and that would be taken as a positional input, right? So by matching the proper position, Python interpreter, a Python compiler assigned 30 to the variable x. All right. But here, if I say x equal to 30, then I'm specifically mentioning the name, input name x must be assigned a value 30, right? So I specifically mentioned that in this scenario, right? You get this, right? This is not very difficult to understand, right? So Python says that the moment you do something like this, the moment you use the name of a variable to assign a value to it, okay, you can no longer use positional argument. And of course, there is a reason for that. Try to understand. If I say, if I call this function, and there is a reason why this is happening, right? If I say parabola and say b equal to 1. So what I have essentially done, I have modified the value of b from default value 2 to 1, right? Now, unfortunately, the concept of order or position is no longer valid, right? The concept of order or position is no longer valid because now this is ambiguous, right? I do not really know what position am I considering the value of x for, right? What is the position of A? What is the position of C? Is it so that because I called B first, am I assuming that B is having the first position here? Or is it that I am maintaining all the positions, right? So basically, the moment you assign a value with their name, okay, assign a variable with their name like that, moment you use something called the keyword argument or position or named argument like that, you essentially break the ordering, right? You essentially say, make the ordering of the variables ambiguous for the Python compiler, right? So it does not really, it cannot really figure out in which order you want the variable names to appear, right? So the ordering automatically breaks the moment you use positional argument, named arguments, right? The moment you assign variables like that, you can only assign variables like that. You get the point, right? So if you say something like this, you can no longer assign the value of x like this. This will be invalid. You can say x equal to 30. That will be absolutely fine, right? That is going to work, right? So you can keep on assigning positional arguments and then you can assign the keyword arguments or named arguments. But once you start using named arguments, all you can do, you can put named arguments. So this is the way. Parabola. So x was like that. So I can use x as a positional argument 30. Then of course the next positional argument is a. So I can say a is 3. Now a is 3. See, I did not say a equal to 3. I could just use positional argument, right? Now I can use positional argument, like I can assign b equal to, for example, 10, right? And then I can say c is equal to, for example, 10. C is equal to, say, for example, 12, something like that. So here x is equal to 30, a is equal to 3, b is equal to 10, and c is equal to 5. That's fine. That's fine. This is fine, right? Now, what if I take this function? So, of course, this is positionally assigned to x. This is positionally assigned to a. What if I want to assign b as a keyword or assign b with its name, right? This is not going to work because the moment I use the name of a variable, the chain or the order is now broken. Okay. Python compiler no longer understands in which order you want to take them. So the chain is broken. This is not going to work. Okay. This does not work. It says again, same syntax error, exactly. Okay, but what you can do, the moment you use the keyword argument like that, or a named argument like that, then all the variables that would appear after that should be used as named arguments. So this is going to work. So positional arguments first, then named arguments. But my recommendation, and also the recommendation of many expert Python programmers, is that unless it is absolutely understandable by the function itself, always use named arguments. Always assign variables with names, right? Because that way your function is pretty understandable, legible. No one really have to dig around and figure out what your function does. And again, I'm just using numbers to keep it simple. This could be any Python object. Python can take any Python object as inputs and return any Python object as output, or any number of them. Okay, you can mix and match any type of Python objects and send them as input to a function and return outputs as any number of any type of Python objects. Doesn't matter. So I'm just using simple integers just to keep the ideas simple here. Alright, someone had a question earlier. Say if we want to write a function like sine omega t plus a, okay, what if I want to create something like sine omega t plus a? So of course in that case you have to assign 3 particular variables, right? Something like that. Say so example, say so this is going to be sine omega t plus a. So I have to assign certain values, right? Something like that. So for example, my recommendation in this scenario would be something like t. T is going to be a positional argument because t is probably going to vary. Omega is probably going to stay constant more or less. Okay, so I'm using it as a default argument. Say omega is 3 radian per second, for example, say, and a is probably a phase, so that's also going to be a constant, for example. And of course all these things are in radians, right? That is understood. So in my way I would use this as my definition, and of course I could return simple math dot sine omega t plus a. Right? Of course, in order to do that, I would have to call my math function, so math module. So I would have to do import math. So I imported math, okay, and after that I defined this, and basically I would take the value of t, value of omega, value of a, and just calculate this and return this value, right? So if I say if I just pass in the value of t, like t is 20, I would get a result, something like that. Okay, so if I want, I can pass in the value of t, and also I can pass in the value of omega. For example, omega is, for example, say 30. If omega is 30, that's the result. Or I could say, for example, omega equal to 30. Of course, I am passing the keyword argument. Yeah, like that. That also works, right? So all the definition works here as well, right? So something like that. All right. All right. All right. So I think this is fine, right? All right. sometimes what happens, we like to discard the output of a variable, right? Output of a function. So if we want to discard the output of a function, so for example, I have a function that does not take any input, but it returns multiple outputs. Say it returns a number, and I would want the number, and then it returns certain garbage, and this garbage could be anything, right? I do not want to really use this, right? Maybe, and YouTube is giving me a warning that the stream's current bitrate is higher than the recommended, so maybe that is why my computer has been pinned. I shall see. Okay, and maybe after that I have a list, that is also fine. I want that. Maybe something like this. So this function returns three things. One is the number which I want to retrieve. Then there is something, maybe, I don't know, maybe a list or something. I just want to discard that, and then there is a list. I want to have this as well. Okay. So sometimes what happens, that there are functions, many different functions in Python that you might want to use, but you don't want to keep all the outputs, right? So again, if I just call this function, then what happens, this entire thing is returned as a tuple. Okay, so if I call that, this entire thing is returned as a tuple, right? So what I can do in order to I mean get rid of this and only use this and this, in order to do that, what I can do, so for example, say I want to take the 13 value here, then I want to ignore the second value that is returned by the function, and then I want to take the list that is written by the function, and then now if I call this function this way, what happens is that the first return, so this function returned three things, right? Thus the first return actually gets assigned to this value, my num, right? The third return, which is the list, gets assigned to this variable, but the second return, which I want to ignore, is ignored. And if you want to ignore a variable or ignore an output, you just assign it to underscore. Okay, underscore basically a ignore variable sort of. So now if I say my num is 13, my list is this one, right? And this is pretty much ignored. All right. So again, these are the things that you are going to use in your curriculum, right? All right. So again, if you have any query, feel free to ask. All right. So now let's create a simple function, right? That actually does something, right? So in the last class, we saw a very simple for loop, right? Very simple for loop that actually did print a multiplication table, right? So let's see. For example, we had this. We had a very simple for loop, right? Say we say for number for say for example in range say 1, 11. Okay, we say print, and we've used a formatted string, for example. We say, of course, before that we assign a variable, say number equal to 13. We want the multiplication table for 13. So I would say number, then I would have a proper string like that, number into n, and that gives me number into n, right? Right, so that is how you use f string, right? So if I just run this, I get a simple multiplication table, right? A very simple multiplication table, no problem with that. But what if I want to change this? Okay, I might want to make this a 15, something like this, and if I run this again, I have the multiplication table for 15, right? Same thing. All right, now with that said, what if I want to turn this into a function? What if I want to turn this into a function such that this number here will come as an input of the function and the output will be this print? So the function is actually not putting any output per se, but it is going to print whatever I want here, like that. Okay, so what I can do, I can take this entire for loop and put it inside a function. So I'm calling this multiplication table. Okay, and I'm going to send in the number from this, and inside this multiplication table I would have this. See, now look at the indentation properly. So I have the multiplication table, this is a function. Okay, this takes number as the argument, as the input. Okay, and then it does this for loop, it runs this for loop, for example. Okay, and this for loop is ran from 1 to 10 for these values, right? And then we print all these things, but this number is actually taken from this. Now look very carefully, this print statement belongs to the for loop, and the for loop and print statement, this entire thing belongs to the function. So the indentation pretty much tells you who belongs to which functions or which statements belong to which statements, right? So the for loop actually belongs to the function, and this print belongs to the for loop. So in turn, the print also belongs to the function, right? By means of going through the for loop. So now if I say, see, my function does not return anything. My function only has a print statement, right? It does not have a return statement. So I can say multable 19. So now if I run this, so now I have printed the multiplication table for 19, right? All right, this is fine, I think. Oh, right. All right, so again, all you have to see, so let's create another function, right? Let's create again, one of the most popular function is factorial function, right? So you have all seen that, right? So what is the factorial function? Basically, so factorial n, if n is an integer, factorial n is 1 times 2 times 3 times 4 times up to n, right? So essentially what you do, you run a for loop starting from 1 and ending at n, and just multiply all the numbers, right? Like that, not an issue. Python has a built-in math function called factorial, so I don't have to write this. So I can just say math.factorial and pass in, for example, something. Python has a built-in factorial function, and of course factorial 100 is so big. Okay, factorial 100 is so big, right? So let's create a factorial function, right? To see that it is matching with our result here. So I'm using a different name for this. So my factorial, of course, I'm going to pass in n. Now, of course, I'm using n as the variable name, even though this is kind of not recommended. But since the name of the function is factorial, it is understood that if n is the input, then I'm probably trying to calculate n factorial, right? So as long as the nomenclature, the syntax is unambiguously understandable, it is fine. Someone is asking, okay. Someone is asking a question on the previous one. In Python, whenever you are considering the range or something like that, it is starting from this one, starting from 1. So for example, for this range function, it starts from the first argument and it goes up to, but not including the last argument. So if you say 1 comma 11, it goes up to 11 but not including 11, and that is true for pretty much everything in Python, right? So it goes up to but not including the end of the range. So that is also true for slicing, right? So when you did string slicing, string indexing, array indexing, list indexing, things like that, we went up to but not including the last arguments, right? So it starts from 1, goes with the increment of 1, ends at 11 but not including 11, like goes up to 11 but not including, up to but not including. That is why we are writing 1 comma 11. So we are going up to and including 10, not up to and including 11, right? So this is something we actually discussed in our last stream here on this subject, right? So now talking about the factorial function. So 0 factorial, you people know 0 factorial is 1, right? 0 factorial is 1. And so the default value of the output is 1, right? So I'm saying, calling this the product, right? So the product is always 1, right? So that's the minimum thing, right? 0 factorial is 1, 1 factorial is 1, and of course up to n, I have to go up to n again. So I have to multiply with a for loop starting from 1 and up to n, right? Up to and including n. So I would create a for loop for, say for example, value, say, I would say value in, rather number, in range, number in range 1 comma, so starting from 1 and going up to n plus 1, because try to understand that I need to consider numbers from 1 up to and including n, right? So that is why I'm writing n plus 1, because if I just wrote n, then what would happen? Up to and excluding n would have happened, right? Would have happened. So I'm saying up to and excluding n plus 1. So of course it is considering up to n, right? Up to and including n, right? So that is what it is. So it counts up to. So of course for this entire thing, my new product value would be the old product value multiplied by this number, right? Right? So now this for loop is over, right? And again, you have to notice very carefully here. And I'm saying then return the product. Now look very carefully who belongs to whom, right? So this product, of course, everything, all of these things are indented, right? So like that. So everything belongs to the function itself. So this product is a constant variable like that, and that is a part of the, and again, these spaces here, these new lines here, these are just my choice, right? So this is something that belongs to the function. Now here is a for loop, right? And this line belongs to the for loop because of this indentation. Look very carefully, right? This line here belongs to the for loop, right? But this return statement does not belong to the for loop. This return statement is a part of the function, right? So after calculating this product, I am returning the output, right? So again, something like that. So if I run this, and now if I say, so again, sanity check. So let's say factorial 0, of course factorial 0 has to be 1. So factorial 100, let's say a factorial 100. Of course this has the same result, like 93326, and this has the same result as the built-in function. Okay, so yes, like that. So I'm saying say my factorial 52, yeah, this way, a huge number, right? Just as a simple interesting fact is that, what is 52 factorial? So if I give you a deck of cards, right, deck of playing cards, so you have 52 cards, and if you randomly shuffle them, then question is, in how many ways can you shuffle a pack of cards, right? pack of 52 playing cards. In that case, so question is, in how many ways can you arrange 52 different objects, right? So 52 different cards, so 52 different objects. In how many ways can you arrange 52 different objects? The answer is very simple, 52 factorial, right? 52 factorial. So this number here is the value of 52 factorial. Okay, what is 52 factorial? Again, this is in how many ways you can shuffle a pack of cards. So basically, in how many ways you can arrange 52 different objects, right? Right. So these many ways you can actually shuffle a pack of playing cards, right? Why am I saying this specifically? I'm saying this because this number is actually way larger than the number of particles in the entire observable universe. So the universe we can observe theoretically, in this entire observable universe, there are less number of particles than the number of than the ways in which you can shuffle a pack of 52 cards. So let that sink in. This number is so large. So the ways in which you can shuffle a pack of 52 playing cards is so large that if you right now take a pack of 52 cards and shuffle it, you have a probability that you would end up with a shuffle that no one in the entire history of the universe ever got, and nowhere in the entire future of the universe will ever get. So this number is so large, really, right? So that's again a very funny explanation to a very simple thing here. In any case, so the idea of basic functions are over at this point. So I think this is fine, right? And again, Python supports Unicode, so the functions could be named with Unicode variables and such and such, right? So like that. So if you have any query, feel free to ask at this point, because I'm going to keep this class as simple as possible. I'm not going to prolong this any longer, because we are going to do some things with these ideas that we have acquired today with our next class, and we shall learn NumPy and Matplotlib in our next discussion, which will be like really important. All right. So with that said, oh, just one more thing, before I even before I forget. Okay. So for example, I imported math library, right? What if I want to see what this function is for? What is this math.sine? So if I want to see that in this Jupyter Notebook console or something like this, all I have to do is put a question mark and run this. If I put a question mark and run this, it says, okay, sine x, it showed me a doc string. Doc string means documentation string. It says, okay, so from the math library, built-in math library in Python, I have a sine function, and this sine function would return the sine of x, and of course measured in radians. So this is a very simple explanation about the function that you want to call, right? Very simple, right? Very simple. You get the point, right? So this is the documentation, I say, right? So we just wrote of our factorial function, right? So I say my factorial. So what does this function do? If I put a question mark, okay, it does not say anything, right? It just puts out some garbage, right? What does my factorial say? I do not know, because there is no documentation in our function, right? I did not put any documentation whatsoever in my function. So in order to rectify this, so that people who are using my functions actually knows what this function does, we usually write a small documentation after we define a function. So this is how we define our function, with a documentation string. So, and this is strongly recommended that anytime you create a function or a class or something like that, you always put a documentation string. So all you need to do is put triple quotes like that. So it put triple quotes, and here of course triple quotes would enclose a string, right? So triple quotes. So I would say this, again, this is not the recommended, I mean what I'm writing is, it has proper syntax and everything, but let's for the moment be happy with this. I'm saying this function returns the factorial of n. N has to be a positive integer or 0. So, and of course this now this is a string. So when I define a function, if I put a string right after the function like this, so this appears as the documentation of the function. Now if I want to figure out what this function does, and with a and put a question mark like this, then I would say that this help here will tell me, or tell the user, for example, what I just wrote. I just wrote this one. This function returns the factorial of n, positive integer or 0, something like that. So the function looks like this, my factorial n, and we have sort of a helpful documentation, right? And not only that, after writing my factorial, and if I just hold on a bit, hover the mouse over this one, okay, I wrote the my factorial function and hover the mouse. So I just took the mouse cursor and hover over it. Now it says, look very carefully, it tells this function returns the factorial of n, positive integer or 0, something. So that way you just have created a documentation of your function. Okay, create a documentation of your function. And this is strongly recommended that whenever you create a function or a class or something like that, you always put a doc string at the very least, so that actually you're trying to help yourself really. So that way, whenever you come back to your function later on, you actually know what your function does or what your class does, right? So that is a very simple documentation. I wrote a single line, but that actually turns out into a help function, right? So, right? And as engineers, I'm telling you, because I am an engineer, so as engineers, I'm telling you, 50% of your job would be documentation, right? So the thing is, as an engineer, you might create a very, very powerful, very useful thing, right? But unless you tell people how to use that, unless you properly document your work, okay, unless you properly present what you have done, okay, unless you properly write help functions or properly write help documentation, so that other people can understand what you have done, or other people can understand, so that others can actually understand what your work does, or what your function does, what your program does, no one will be able to use it, right? You have created a wonderful thing, but no one can really use it, because no one really knows how to use it, right? So your success will be very limited in that sense. Okay, so as engineers, 50% of your job would be documentation, right? 50% of your job would be documentation really, okay, to help others use your work. So that way documentation is very important, right? So it is not just writing comments in your program, it is helping people, those who are going to use your functions, use your classes and everything, use your programs, right? For them, writing comments in your internal program is not sufficient. You need to create a help manual, right? So this is the very first step into that. So my recommendation is that whenever you my recommendation is that whenever you create any function, always put a doc string like this. So this is a doc string. Okay, so whenever you create your own functions, for example, I create a multiplication table. So if I put a doc string, I would say this multiplication table for, of course there are certain syntaxes, you don't have to worry about those, right? So now if I do this, and again same, if I do the same thing, if I look at mul table, okay, and I hover my mouse over it, so it again shows me the documentation of that that I just wrote. It says multiplication table for number, right? Like that. So you get the idea here. So you're helping others use your program. So unless you help others use your program, no one is going to use your program, no matter how good your program is. With that said, we're going to end our discussion today here. So I think there are a few things specifically in Python 3.8 there are certain changes to the functions nomenclature. We have something called positional only arguments, but those are in Python 3.8, but Google Colab only runs in Python 3.7, so I cannot really show you that. But again, as beginners, you don't even need that. But with that said, these are right. So if you have any query, feel free to ask. I'm going to end our discussion here, and I will see you tomorrow with our control system theoretical classes. We shall talk about Laplace transforms. So basically mathematics classes, right? Any question that you might have, feel free to ask right now. Alright, so if you don't have any question, so I'm going to end the stream today here. So of course I would like to put a homework here. So a very simple problem here. So your point would be to create a Fibonacci series, right? A function to generate Fibonacci series. So I would create def, and of course I would pass in n, and again I'm writing the doc string for you. So this function returns the nth Fibonacci number. So nth Fibonacci number, right? So do the function and do the function, write whatever you want here, okay, so that it returns the nth Fibonacci number, right? And start the Fibonacci series with 1. So 1, 1, 2, 3, 5, and like that, right? So you know the Fibonacci series. So you do this, okay? So I'm sharing this file with you. And also this file would be linked in the video description as well. So copy link. So try, so if you need this file, so here it is. And so that will be the end of today's discussion. I think I made the ideas of Python functions pretty clear here. All right. So again, if you have any query after this, feel free to drop me an email. I'll be definitely answering your queries. Thank you very much for being here and being patiently waiting there for 1.5 hours. And I'll see you tomorrow. So thank you and bye-bye.